In this video, we're going to learn how to find the area under a curve. This is a special case of finding the area between two curves, but in this case, the bottom curve is the line y equals 0. So what are the important points when we're finding an area under the curve using integration? Well, the first is there will be no constant of integration, and we'll see why later on when we look at an example. The next one is that areas need to be positive. Now we'll see why that's important with part 3. And that is that if we find the area under the axes, the answer we will get will be negative. What we've got to do is then change our answer into the positive value. And finally, if the curve crosses the axes, we'll have part of the curve under the axes given a negative value and part of the curve above the axes given a positive value, and they will cancel themselves out to a certain degree. So it's important in those situations we work out those two areas separately and take the positive value of each and add them together. So how do we find an area under a curve using integration? Well, first of all, we're going to look at our question and we're going to set it up like this. We're then going to get to the next stage like this, which we're then going to solve to get our answer. So what is A? Well, A is the left-hand limit, 1, and B is the right-hand limit, 3, and f of x is the curve that we want to find the area underneath. So we need to integrate f of x and put it in here. So we integrate the function. We substitute in the b value, the right-hand limit, into the function here. We then substitute in the a value, which is obviously our left-hand limit here, and then we subtract 1 from the other, and that will give us our area. If the area is above the curve, it will be a positive value. If it was below the curve, we'd get a negative value, but we would change our answer into the positive one. So let's have a look at an example. I've made it a simple polynomial, but it does work with any function, but I didn't want us to get confused with our basic integration. So here we're finding the area between this curve and the axes. You might remember that we're going to get a negative answer. So let's first of all set up our integration. So our left-hand limit is 2, our right-hand limit is 4, and the curve we're interested in is x squared minus 3x minus 10. So we set up our axes. This is the result of this integration here. And we're going to substitute in 4, and we're going to substitute in 2, and we subtract 1 from the other. That gives us the answer, minus 58 over 3. Our answer we want to write down in the end, though, is positive 58 over 3. So now let's look at our last example. In this one, it's the same curve that you can see here, but part of it's below the axes and part of it's above the axes. So the initial form of our integration might look the same. We do want the area from 4 to 6, but to calculate that area correctly, we need to split it up into two parts. We need to go from 4 to 5, and we need to go from 5 to 6. And I've put these modulus signs in here because we want the positive value of each. And we work these bits out in exactly the same way we did for example 1. So for this first one, we're going to get 19 over 3. For this next one, although we'll get negative 19 over 3, we want the positive value. For this one, 23 over 3. And we add those together and we get the answer 7. In the description below, you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Staying in field with Winfield.